going to keep it relatively brief in terms of the actual me standing up and talking at you bit, because I want to move on to a bit of an interactive kind of engagement with everyone in the room, see where they think maybe these new kind of extended reality technologies are kind of going. But I'm going to start with a brief introduction to WATERLINE, kind of tell you what it's kind of all about, the kind of key kind of objectives of the project. And then I'm going to talk a bit about XR technologies, so these extended reality technologies like virtual reality, augmented reality, all of the above. And then kind of talk about how that is then being used by a few of our project partners across Europe to develop these new educational virtual reality apps to teach water systems engineering in higher education institutions. And then we'll move on to a bit of engagement. I've got a Mentimeter kind of ready to go, but it might end up failing and we'll just end up kind of going. Depends on how many online participants we get. At the moment, I think it's just Albert. So, so we might just keep it kind of analog and maybe just have that discussion in the room. So I will start with a quick overview of the WATERLINE project. So the vision is to establish a leading European digital water higher education institution alliance. It's a bit of a mouthful, to spearhead innovations in water systems engineering. Essentially, we're wanting to use kind of cutting edge digital and extended reality technologies to kind of transform educational and research kind of institutions and the whole kind of waterverse in general. And this is kind of done through this collaborative model. So it's based on what they're calling a quadruple helix innovation model, which I'll kind of briefly try and expand on a little bit in a couple of slides' time. But basically, this kind of intertwines academia, industry, government, and civil society into kind of creating this digital water domain ecosystem. And finally, the strategic goals of the project are to develop research, education, and entrepreneurship capacities. So boosting those capacities to essentially promote knowledge exchange between the whole of Europe and address challenges related to water management. So here is a screen full of project partners. I won't go through them all. Some of them I can't always pronounce properly, so I apologise. But our lead is MCAST, and I'll be talking about Mendel. They're two of our project partners that are creating these apps. Well, I'll kind of go over this in a bit more detail when we get to that section. But anyway, need to say that basically it's a wide-ranging European project. So what are the key objectives of WATERLINE? So this breaks down into alliance consolidation. So the idea here is to co-create a governance framework and a research and innovation capacity building plan. Supporting this alliance is cohesion and operational excellence. Another key component is educational transformation. This is developing a portfolio of master's level water components and transform the traditional labs into assisted and virtual reality spaces. This is what I'm going to kind of concentrate on talking to you about today, is kind of how do we develop applications that can be used at master's level to really kind of augment and enhance the learning experience of students studying water systems engineering. Another key component is research and innovation capacity strengthening. So it's pretty much what it says. Basically, we're trying to kind of enhance those skills within the researchers We're running lots of workshops. We're running summer schools. Quite a lot of you probably saw the WATERLINE summer school that we hosted here in Exeter last summer. And also kind of promoting this kind of academia to business interaction. Following on from that, networking and knowledge flow. Again, it's kind of establishing these networks of academics and researchers, but also we want to kind of strengthen that within industry and in civil society as well. And then finally, sustainability and impact. So essentially, the vision is that we end up developing an ambassador network, and essentially we want to make sure that the project lives on after the kind of funding runs out and the project comes to an end, by identifying further funding opportunities and kind of creating kind of new opportunities and new kind of synergies within EU initiatives and projects. So this quadruple helix model of innovation. So just to kind of go into this in a slightly more detail, basically the definition of it is a collaborative innovation model involving four main actors, as I said: academia, industry, government, and civil society. So the idea is that academic component provides our research, knowledge, educational expertise. Industry, practical insights, challenges, solutions, and fostering that entrepreneurship. Government supports with local policy frameworks, funding, regulations, that kind of thing. And then civil society ensures that societal needs and sustainability considerations are met. So the idea behind this is that it promotes a comprehensive multi-stakeholder approach to innovation and facilitates the creation of a sustainable learning and innovation environment in water systems engineering. So moving on to extended reality in water systems engineering. I don't know, can I have a quick show of hands has everybody heard the term XR before today, extended reality?
I've never heard it.
Okay, just but a smattering, I suppose. It's not an overly well used term at the moment, but who's heard of VR or virtual reality? Pretty much everybody. So XR is this kind of overarching term for anything like virtual reality, augmented reality, mixed reality, assisted reality. These are all kind of come under this extended reality, extending the reality of yourself, I suppose. So VR, probably all seen it and maybe even tried it. So this is a fully immersive immersing kind of technology. You put a headset on and you're completely kind of cut off from the real world. So you're in a completely virtual world. You can interact with virtual objects and what have you, but pretty much all that you see and hear, it's virtual. Then you have augmented reality. So this is slightly different. This is basically taking the real world and then overlaying kind of artificial things onto the physical world. Technology like the Microsoft HoloLens is kind of a good example. But we're starting to move into something we call mixed reality. So this is whereas AR, you tend to have a bit of glass and you can actually, your eyes can physically see the real world. Mixed reality, you tend to have a pair of cameras that are seeing the world for you, and you're still seeing in the headset the real world, but through some cameras and some screens. And with that, that gives you some different abilities, because you can then mix the real world and then the virtual world and kind of join them a little bit more coherently than, say, with augmented reality. And then finally, you've got assisted reality, which tends to be denoted as a small a, and then to kind of differentiate it between augmented reality. But this is essentially I always kind of think about the Mission Impossible guy with the glasses on, with the camera in it, the earpiece, and maybe a little overlay on the glasses, kind of showing, oh, that's, you know, Dave and that's Fred, and doing facial recognition. And there's always someone on the end of the phone saying, you know, telling Tom Cruise to run down a bridge or something. So that's more assisted reality, and that's pretty good for kind of training environments and that kind of thing. Where you've got someone, an expert on the end of the phone, who can tell you how to disarm the bomb or fix the, you know, the valve in the water treatment plant. So XR technologies, they're not that new. They're coming into kind of, they're getting quite popular again. But there's been quite a lot of use of XR technologies in learning and innovation and education. So there's quite a lot of kind of real world applications for these technologies, which I'm kind of hopefully come on to now. So as I mentioned before, one of the key components of this project is to essentially develop these kind of virtual learning environments. So this is using kind of immersive and digital kind of technologies, mostly kind of XR, in this case, a lot of virtual reality, to essentially augment and really extend the kind of educational experience of students. This is kind of aimed at master's level, and we've got four of the project partners are developing apps and the accompanying kind of curriculum for teaching master students. So the first one is MCAST. They are looking at developing a virtual reality water network simulation. I'll kind of I'll kind of talk about these in a bit more detail on the following slides. The next one is Mendelow's flood kind of variation. So this is kind of visualizing different flooding scenarios using kind of GIS data. Then we've got a dam break flood experiment. So this is kind of, what if a dam breaks? What are the knock-on effects? You can kind of go down to kind of ground level or water level and kind of experience what it's like. And then finally, we've got a losses in a pipe system VR experiment, which is essentially a digital twin of a real world kind of experiment that you might find in the fluids lab. So starting off, look at MCAST's application. So MCAST, they've built themselves a kind of state-of-the-art water rig. It's kind of custom, and it allows students to kind of play around with different pumps and valves and kind of, you know, basically learn all about the kind of operation and design of water distribution networks. Thing is, this thing is in I think they only had a space for a kind of a tiny room, and you can only get 2 people in there at once. So what they've done is basically build a digital twin of that rig. Now this is currently in development, so it's not kind of all pretty and what have you, but they've got the basic functionality there now. So by having a digital twin, that runs on a headset, you can give that headset to a student, or you can give multiple headsets to multiple students, and they can play around with it, kind of turn valves off, change the pump speeds, and do whatever they want, see immediately what's going to happen, and quite nicely, they can't break anything, because, you know, it'd be quite easy to, you know, kind of break a pump or a valve or burst a pipe or what have you, potentially on the physical model. And with the digital twin, you can have multiple people working on the same model at once. And in terms of the cost, in terms of replicating that device, it's a lot cheaper, because maybe a 200 quid headset, I think it costs quite a lot more to build one of those rigs. So that's MCAST. They are progressing very well, and quite hopeful to kind of, we'll hopefully see kind of the final product in the next kind of month or so, or at least a final prototype. I'm just very excited about. Moving on to this flood impact kind of modelling. So this is essentially, they've got a way of visualising pretty much any GIS data. I think they're using Unreal Engine to essentially stream real world kind of satellite topology kind of data, and then they can overlay flood data onto that model and then kind of view it and interact with different kind of parts of it. This kind of, the idea behind this is you can try different kind of mitigation strategies to different kind of flood scenarios and that kind of thing. So again, that's looking quite promising. Moving on to yes, the VR assisted dam break flood experiment. So in their fluids lab, they have a really nice concrete model of a dam, and they can simulate kind of it bursting and what have you. And then they basically built a twin of this, and they can run their kind of dam burst or dam break flood modeling, and then lay this over the kind of a 3D representation of the area. And so you can kind of see a bird's eye view, or you can, as I say, teleport down to the kind of different points in the environment and kind of experience kind of where those kind of water levels are for different kind of failure modes and what have you. And then finally, Uni is exploring pipe system losses with VR. So this is essentially an off-the-shelf kind of losses in pipe system experiment you can buy, and the idea is it kind of teaches you using different kind of sensors. I think there's something very similar in the fluids lab. Albert probably can confirm. And essentially, there's different kind of diameters of pipes, different joints, and what have you, and you can plug kind of your kind of sensors, so that's more kind of tubes to work out the different pressures and the pressure losses in the system. And so what these guys are doing is trying to essentially recreate this, but in virtual reality. So underlying, they've got the kind of all of the hydro equations that can dictate the pressure losses and what have you. And then they can kind of tweak different things and see the outcome and kind of report the results. So that's the kind of 4 applications that we've been kind of helping our partners kind of develop over the last kind of 6 months or so. And essentially, kind of want to think about how these XR technologies can really enhance engineering education. So obviously it's this kind of immersive learning. So XR technologies can create these really immersive environments that mimic real world scenarios. So a lot of the time you can't experience a dam break in real life because you wouldn't last long, but being able to stand down, downstream of a dam when it breaks, that can really kind of sell the whole why this is important, right? And so it might not just be for education, but it could also be for other stakeholders. So we're talking about selling different policies and say, if we don't do something, then this bit of coast won't be here anymore, or this village won't be here anymore because this dam's going to break, or what have you. So essentially, the idea by using these technologies is to really kind of enhance the understanding of the users and the students. Hopefully, it also aids in skill development, and it also helps with engagement and motivation. So I've got a few examples here with XR in the real world, how it's being used. So there's a couple of kind of case studies here. One is Melbourne Water. They improved their hazard identification using VR. Essentially, they modeled their kind of pipe system and were able to use it to identify different kind of breaks and leakages and hazards. We've got examples of VR tours for kind of eco-friendly water treatment facilities, and this is more of a public outreach engagement kind of thing, where it's essentially kind of showing why it's good to invest in these kind of water-friendly treatment facilities. Yorkshire Water, they adopted some VR advanced visualization to prototype some of their facilities before they're built. So it enabled their engineers, their technicians, to kind of experience the whole facility while it was in design, and so they could flag any potential issues and what have you. And they think that it, saved them over £1 million by implementing this system. And we've got a few other examples. Again, this is kind of exploring new production sites and then also enabling a kind of training of new sites. So again, you can kind of, before a site's even built, you can throw a technician in there and train them up on the facility that doesn't even exist yet. And then the final one is talking about mixed reality and augmented reality. There's an example of an application allowing an engineer to kind of go out into the field and see buried pipes underneath the ground, which kind of really helps kind of the engineer kind of make decisions in the field, because you've got a lot more information. You can say, okay, that pipe's there, okay, it joins there, and then I need to kind of take that into consideration before kind of digging a hole in the ground. So that's kind of the end of my kind of talk, I suppose. What I wanted to do, I've got a few questions up here to kind of start the kind of conversation. But I suppose the first thing was, first question is, in what innovative ways can XR technologies be further integrated into water systems engineering, education and research? I know a lot of you in water systems education and research. So can you think of any ways that these technologies, XR, could be further integrated into your research, say, or maybe some of the modules that you teach? I don't know. I kind of leave it to the floor. Yeah. Okay.
Have you used any of these things to look at community engagement for flood risk? Because you can almost go around to people's houses if you've got a flood model loaded at the street, and you could show them how high flood waters might get at different stages.
I know that's an idea, possibly in the pipeline, isn't it, Albert? I think I don't know if is that something that you were looking at using VR for.
We previous work on in another project, EU Circle, will try to produce some 3D flood simulation results to engage with the stakeholders, and we didn't put that in the VR. So it could be a good idea. We also had this feedback from Tom this morning that would be an idea, try to turn that in the VR application to let people stand in the water. They have this stronger feeling than just looking on the map. Yeah.
I think one of the biggest problems, particularly for sort of distributed green infrastructure, is actually convincing people that it'd be good to have something on your own home phone.
Yeah.
And I could imagine if you could almost go to someone's house with a VR goggle when you're sort of knocking on doors and say we're offering. Often the water companies will put these things in and pay for them, but people don't want the work done.
Yeah.
So something like that might be quite convincing.
Thank you. Yes. Good. I just put in the chat.
Okay.
The short video we had last week about the prototype.
Okay. Okay.
So that's the one Matt mentioned. So we can. So here's the sound if you, or you want to go explain.
No, as Matt knows, I know very little about water, but I'm starting to learn a bit. But thanks to Dr. Rizzo, this is, credit to him that we all the time meeting up and liaising between the IT team, our IT team, and the water experts. So as you can see over here, we can literally click on any pipe. We've got visualizations using color for flow in pipes. So for example, if I increase the pump strength, you can immediately notice that the blue signifies a higher flow. The red is low flow. And as soon as we start closing and opening the different valves, we will see a difference in the color, signifying a difference in flow. We've also got solenoid valves. These are real in the real water rig, which we can obviously manipulate as well. So like, for example, opening this valve and closing this solenoid valve. You can hear also the sound of opening and closing each.
So they built this, what Matt introduced earlier, so built this virtual system, so linking with the physical bench they have in the lab. So, and that we had a summer school last summer, and they came here and Matt shared the experience of what it created in the house project, try to link with the virtual reality with the EPA net modeling and to link this together. So basically what this been doing will link to the EPA net to get the result directly feedback to the change of the network to visualize them immediately, allow the user to see what condition has been changed. When you switch on any of the valve or any of the pump, so you will be able to explore that. And the idea, this one, they also incorporate with the sound. So that's want to use that as a training for the engineer. So if you want to detect leakage, you might be able to follow the sound to find where the leakage could be. And then and we also discussed that this one is currently working on the bench to link with the what they had in the physical experiment as kind of digital twins of the applications. And we talked about that could also for further application, we can scale it up, allowing the user to change dimension of the pipe with much larger scale to mimic a water distribution network in the real environment. So that's, we've been working with our partner on this part of this application. David?
Asking you a question on the what is our role at Exeter in the project?
So we had experience doing this kind of house project. Matthew was involved and linking with this VR application. So he shared this knowledge, and also guys are also working on the development different dashboard applications or linking with the sensor data. So we are helping them to strengthen this one. And also the other part of this one, we are also discussing about to shaping a master degree program. So we didn't have time to put at this. That we have 20-ish modules for different threads. So learning the basic foundation of the water resource knowledge, and also the technical skill to use the hydroinformatics or different tools, and also to do the analysis of the data So this we are currently developing this master program. Certainly, we want to have your opinion and to help us also to shape that. Hopefully, we can come up with this program, and then we're allowing all the partners who want to further develop the digital water education. They can use this kind of as a template to further develop the curriculum. And also, we want to see if the possibility we can deliver some module via the common platform, via online platform. We are also putting out together as a MOOC, also allowing the people to learn the contents of the knowledge, also to use the tools we developed, created in this WATERLINE project. Adrian? Yeah.
Sorry, yeah. Can you break the pipes?
In this, not yet, although there is talk of simulating leakage.
I think you need more catastrophically, because it's nice as a simulation of if you like a perfect system, but the systems aren't perfect.
Yeah.
So the video showed people the user just opening and closing the valve.
Yeah.
You don't just open and close the valve.
Right.
You do it over a period of time. It's things like that if you don't educate people with these tools, you need to educate them in a way that isn't destructive to the real life system.
Yeah, that's a really good point. I think it's a lot of the effort has been kind of going into the kind of back end and kind of how do they link this up with Ethernet, and then how do they calibrate it, which has been quite a big issue, as to the physical system, how that matches up with the virtual system. But that is a really good point, and something that although it's a good thing to be able to break it in a virtual setting, you're completely kind of safe, and you're not going to cause thousands of pounds worth of damage and flood the lab. But that is a brilliant idea, and I don't know whether they have considered it, but
they do have considered it.
They have considered it.
Yeah. So they currently the focus is try to calibrate model against the physical bench they have.
Yeah.
Make sure everything's properly simulated, presented in the system, and further applications you want to push the boundary to something that's not possible for real world that we want to test on this bench.
Is the bench too small for something like EPA net?
No, this one is working. Yeah, because EPA you can have only couple pipe, very single loop.
I was thinking just measuring the pressure changes. It's almost too small.
Yeah, so head losses are very tiny.
Yeah, so let's just try to do a prototype, and we will try to see how can we make it more realistic at this moment. Yeah. David?
I noticed that the examples you gave, I think were all producing the visual side of digital twins that were representing physical system.
Yeah.
And there have to be lots of applications of that in the real world where digital twins are representing major real systems. And the only one that springs to mind at the moment, one is you have to be careful of scaling up, because visual techniques that work at a smaller scale may not work so well at a full size scale. But the question of escape routes from floods is, it's easy to put some simple algorithms that will say, well, this route will stay dry for a certain time. But real escape routes are rather more subjective than that.
Yeah.
And I think human involvement in working out how best to evacuate a lot of people, potentially trying to go the same ways or getting stuck in cul-de-sacs. I could see that a lot of visual practice with that would be really good.
Yeah. I think
it's away from the simplistic approaches.
Yeah.
Something a bit more human based.
That's a really, really good idea. I'm thinking about the kind of VSIMs could be quite immersive.
There's a lot of opportunity we can explore, particularly with what you said. Water may not flow what we want, and people certainly will not behave what we want. So it's involved this study about how people will react during this kind of under very stressed environment, and then so and how the virtual environment we are creating, would that be good enough to represent the condition and to capture people's behavior? And there's a lot of things. So we have this CV simulator there, currently work with people from the medical school looking to the elderly people, the health and the safety, the response. But we also talk to them and want to explore the idea to maybe simulate some fuzzy simulation on that platform, and adding that the uniqueness of that the system, the infrastructure is not only what you have put in the virtual environment. They have the movable platforms, 6 axes, so they can move up and down, give different vibration, get a little bit more close to the reality feeling. And they also have the capture screen to capture how you react during this kind of situation, so that we will be able to analyze people's response during the situation.
Yeah, a quick one. I imagine you could couple an agent-based model to the virtual reality model. And, I don't know, is that part of the agenda, or is that a step too far?
I mean, for WATERLINE, for this project, I think that's probably beyond these kind of initial prototypes and the development of the kind of courses around them. But these apps and these developments kind of offer a really nice platform to then come up with these kind of really innovative ideas. And that's where you kind of springboard off into hopefully some more funding and some more kind of projects and development.
There's certainly for escape routes and flooding with crowds, it's been quite common in the past to do that using CFD. So your crowd approximates that flow.
We had a group of students last year. Basically the similar group that done similar project multiple times in the last couple of years. So last year, the students that used the Flow 3D to simulate how water entering to the underground station, and then to see how the water would go into different parts of the station. And there's some other students trying to look into how will people evacuate. So looking to the agent-based model. And we also link into the psychology. So if you want to evacuate people, what kind of signal we need to give them and to direct them to go out. But all this kind of individual component we haven't tested. There's no student tested on the virtual reality. So they only just to use different model to simulate. And also one try to use the facial recognition to count head. So how many people in different part of the station. If you want to evacuate people, we don't want to evacuate everyone to one state. So they want to distribute the crowd to different locations. And we also consider into the people with special needs. If you are traveling with the children, or if you are using a wheelchair, so how could we help those people or send stuff to help those people who need special assistance? But apparently that can be brought further to link with the virtual reality to see how really people will behave in this kind of conditions.
Yeah, Albert, there's a startup from Falmouth that was doing a nicer version, or a friendly version of that, which was, again, people tracking, but it was people tracking in tourist attractions, being able to do demand journeys. So you get something like the Eden project, where one of the biomes is really full. So the system recognises that and then directs everybody to the other biome with the cafe. So you may be able to use that kind of approach for intelligent kind of chaos management.
Yeah, the other one that's we recently have a new paper published about when the people in the flood in the car. So how are we going to evacuate people in the car? So are they safe or not when they're walking in the very fast flowing water? So could they be slippery, or there's some other dangers? It might be even safer they stay in the car. It depends. So there's quite a lot of things can also further explore.
We also get from that the issue that people use in cars has on others. So the flooding that happened in Exeter last year, there's loads of videos on YouTube of people having a lot of fun driving their 4x4s through the flood, which then sent a bow wave into properties, flooding them even more. So some of those kind of educational facility things might be worth exploring.
More comments?
Yeah. Sorry. Now, what I was going to say was going back to trying to find useful VR solutions to problems. It might be better. There may be value in flipping that question around, saying kind of as researchers and learning and teaching staff, is what kind of problems are you running into that you might be able to solve, and VR may be a solution. So it's kind of concentrate on the problem domain. I think, for those of you that are able to attend CWS 25, Albert and Matt did a workshop on VR training, and one of the things that came out that I thought was really important was that Albert did some literature review that was basically saying that the VR can be used to teach sort of harder, faster, and deeper than traditional approaches. And I think when we kind of traditionally look at kind of teaching through lecturing type engagement, you've got this kind of ladder of involvement, like kind of a lecture, tutorial, workshop, things of that nature. So you, as lecturing staff, you may find there's certain pain points on the courses that you're teaching where students just don't get it. And even adding more lectures, more tutorials, the students are still refusing to learn the material that you've got. So something like VR or AR or an XR intervention may be a useful pain point reduction in those cases.
Just sort of going back to the comments about the breaking of pipes. I know that South Water has got a rig where they can train engineers to close the valves really slowly so that you don't get a hydraulic transit when you break them. Right. To my knowledge, you can't have hydraulic transits in Ethernet. That's not something that is an emergence system in Ethernet. But you definitely want that kind of feedback. There's a certain amount of haptic feedback that you might get from pipes migrating and we're looking at the real system. Straining noises from pumps or what have you. That's all kind of feels quite important in kind of the overall training and not necessarily a common sense, but kind of an engineering sense of it, that kind of other sense for the system. That feels extremely difficult to implement that into a digital twin or into a VR simulation at all.
I think no. That's a very good point, and it's not an easy thing to implement. It's definitely doable in terms of the technologies there. There's you've got haptic feedback now in terms of your controllers and what have you. You can go for full body haptics if you want, and where you can actually physically feel objects. Kind of special gloves and special suits. So if you want to do it, you can. It's whether you have the whether it's worth, I suppose, the investment and also the time to implement them. But I think you're right. Being able to sell the kind of realism is really important, and especially in training scenarios, being able to physically grab a valve and kind of go through the actions, get that kind of vibration and especially the sound, the feedback. I don't think you have to be 100% real to kind of get the majority of the kind of feel across to the user. But no, I think it's a really, really good point.
I guess the crux of that is whether or not this would be a 100% replacement for training on the real system, because I imagine that you train the bulk of everybody, you do lots and lots of scenarios in the simulation, and then maybe you do one scenario on the real system, something like that, just so that you've got more training time, essentially.
Yeah.
Rather than completely replacing your real system with just a simulation.
Yeah, absolutely.
Yeah, I think I'd add to that is that you don't have to make this precise, you just have to make it close on. The way the software reacts tells the trainee that what they've done would have caused the problem in the real world, because there are other reasons that you just don't close valves, not just transient, but if you're reversing the flow direction from what it was normally, the shear stresses that you put on the biofilms, then you've got a discoloration event. Even if you maintain water supply, you've now got customer complaints for different reasons. So it's that you need to be training people on is what they do, what its effects would have been, and the consequences of those effects.
Yeah. Yeah, no, that's a really good point. As you say, you don't necessarily need that really high fidelity. You know, I can feel every kind of, someone hasn't kind of greased this this valve mechanism for 2 weeks, but just something popping up or a sound or something that says you've just, broke a pipe. Yeah, or just the pipe's flashing red because it's now in pieces.
It's very much the nature of a research-based project. I think what we tend to find with a lot of the projects we've done, not necessarily just with this, is that to start with, the research is this actually possible? So can we actually build a digital twin using Ethernet, and are our colleagues at MCAR capable of doing it? Now we've kind of largely solved that problem. That opens up a whole new vista of problems, which is the fidelity of the simulation you ought to have. And,
what are you trying to twin?
I think from what both of you were saying was, you can see that there is a level of simulation that fits above the Ethernet level, which is basically the kind of the user input level. So if you've got users that are kind of very candid in how they work with that, then we can provide responses that demonstrate that and give the right kind of haptic feedback. It also opens up nice opportunities for water engineering staff back at MCAR, because once they're working with this, they're probably going through exactly the same kind of thought process that you've all gone through here, which is going to be candid with this, but it doesn't make sense to jenny the bells on and off and do all sorts of good, wonderful stuff. Because I know when I went to my demonstration last year, and the water engineering professor there was saying, the students could do really bad things with this. And I think pointing out to a couple of replacement parts that they've put in recently. So, I think this is one of the challenges you run into. Is a lot of the time building any kind of training systems, is you build the normal behaviour, and then you want to go and start exploring the edge cases. And we were having a conversation over lunch about kind of group projects in academia, where the role of the group project is for a disaster. So students can learn the challenges of group projects, and the role isn't, the value isn't in succeeding. And I suspect we can end up going through a similar process with this, where we start looking at those really nasty edge cases and what the edge cases demonstrate.
We did have student flood our fluid lab. So yes, that's possible, and we also have this search tower and water hammer bench, where our idea is trying to replicate that one to simulate that search of the pressure to let students know. And because that's only fixed with steel pipe. So, but if we can replicate it in the virtual reality, we can replace the material pipe to see the different effects of the surge when we close the valve at different speed. So how this will change, and if we have the surge tank, we cannot flood our lab, but we can allow to flood in our virtual reality.
Two of the components of the quadruple helix part of this project were government and industry. What government and industry representatives do you have on the project? It wasn't clear to me.
Okay. So we are organizing this today. We organize a regional community of practice workshop today, and try to engage with people, with government and local authority and the industry, and also we unfortunately select the wrong date. That is half-term today, so we miss quite a lot of audience. But hopefully we'll engage more people, but also we want to involve more, some of these people to becoming a part of regional management committee to help us when we are developing things, give us some ideas, and also help us to grow this network, to involve more people, and when give us what you're expecting, what we are developing, would that be useful for not only for teaching, but also could be for other engagement with stakeholders, other training of the industry. So that's what we want. And we also have another one is I also emailed all of you that we have the ambassador network that we want to build. So we want to provide the training opportunities and to allow this ambassador network to take what we have developed and to implement the idea, to test it. And some of them, they don't necessarily to implement it, they just want to share the concept with other people, with networking, so to help us to grow this communities. And so I sent an email to everyone that we are having another summer school in Norway in June. So we should be able to find support 2 or 3 colleagues from here to go to attend this summer school and to get to learn something about that. And so the closer to the end of the project, we should have the material and code and all these applications be available. We'll make them available on our website.
It might be really interesting to combine what your project is doing in the water sector with what some of the other industries are doing. Yeah. So one of the modules I'm teaching at the moment is building information modelling. Yeah. We have Lang O'Rourke come in and do a lot of the lecturing. Yeah. Their head of digital is a big part of our teaching, and he's often talking about lots of these things that they're just doing up the road at Hinkley Point. Okay. Particularly like the AR, VR stuff, because and at Hinkley Point they've got the model for all the concrete pours and exact specifications for rebar. Yeah. And they're looking through and they're going through with like M&E teams, because, well, let's not get to that, but they're going through with the M&E teams to change locations of things as technology is being developed. Yeah. And you can see through the wall to see where the rebar is being fixed, to see where you can drill new cores through concrete. So I think he's very much of the opinion that that these things are really, really good, particularly for engaging different groups. Yeah. But there's a whole host of different digital technologies they're using, and Hinkley's an absolute exemplar for it. So
exactly. Unfortunately, the rest of the water industry is the opposite of that.
That's quite good similar application. So I saw some company that try already implemented. They use the VR or AR to visualize how's the pipe network in the ground.
Yeah, the new sites are fine. They're using BIM to digitize the sites. But 150-year-old.
Yeah. We might be trying to arrange a trip to see Hinkley. Yeah. So if it's something that, and it would be very digitally focused, I think. So if you guys are interested, I could try and make it more of a thing.
No problem. Yeah. And also that I haven't sent you the curriculum we have created, so I will show you.
That'd be really interesting. Yeah.
I think that's the conversation we had this morning about the thing for me that's interesting around this is the sort of wider context of what's going on in the systems that feed into the pipes and the weather and changing climate depths. Something that's just occurred to me is water supply reservoirs and the role that they might be able to play in flood mitigation. Mm-hmm. So being able to simulate a storm in a catchment with a known conveyance issue, downstream bridge, culvert, whatever, and managing that asset so you can draw it down to try and retain as much of that volume of water that's going through the catchment without having a failure of the dam and with as little exceedance of that structure as possible. So kind of a mass balance scenario effectively, but using a supply asset in a different way.
I'm aware of time, so this is our scheduled time for our seminar. So if you are have other matters you need to look at, feel free to leave. And if you are interested to continue the discussion with us, feel free to stay with us. And I've taken some photos. If you are not happy the photo to be shared on website, do let me know. So we try to not to show you recognize or face, whatever. Yeah. Yeah, and yes, feel free to get in touch with me, Matt. Guys, we've been working on this. We certainly want to learn more from all of you. Thank you very much.
Okay.
Yeah. Next week we'll back to Harrison for the seminar. So Peter, he will come to give us the seminar talk next week. Thank you. So then we have a break and then we continue the discussion.
We don't have to see anything. Wait for this. You have to